Alright, geometry, we are going to do a little radical review. Okay, we are actually in Unit 2 right now, about lesson 20, well, we're in the lesson 25 through 29 range, and we need to review radicals because I just think you guys need a little more practice. So there's no prescribed slideshow with this one. We're just going to review some radicals and review how they all work, and hopefully it'll all make better sense to you. So first of all, let's just talk about this, the square root of 9. Like, what does it mean? Really, it means what number times itself equals 9. So that one's pretty okay. Square root of 9 equals 3. Okay, moving on. Square root of 16. Okay, what number times itself equals 16? That's 4 times 4. So square root of 16 is 4. But when we get into something a little more difficult, like square root of 8, that's when we have a little more work to do. Okay, what we need to do is split this one into factors where 1 is a perfect square. Okay, you guys have a list. If you need another list, you have to ask me for it. So we have the square root of 8. The square root of 8 splits into 4 times 2. 4 is a perfect square. And 4 is the biggest perfect square that goes into 8. Okay, we learned rules that say square root of 4 times the square root of 2 is, the square root of 4 times 2, I can split up. 4 is a perfect square, so I can take the square root of it. Right? I'm going to just review the rules right here. One of the rules we learned, square root of a times the square root of b is the same as a times b under the square root. It goes backwards and forwards. Okay, let's try something a little different. Square root of 27. Now I want to split that up into the biggest factor that's a perfect square, which is 9, and 3. Now I can go, that equals 9 times 3, which is 3 square roots of 3. Okay, when we were learning this in class, we would make factor trees. We would just factor it away. We could say, okay, that's 3 times 9. 9 breaks into 3 times 3 until we get prime numbers, and then we would circle pairs. Like, all right, I have a pair of 3s. I can take that out of the square root, and I have a lonely 3 left over that's in the square root. And that's fine, but as I was looking at your last assessment, you guys are making some silly mistakes. So we're going to try a different route and see if we can eliminate some mistakes. Okay, let's try something a little different. How about the square root of 20? Now you remember, we want to break that into a perfect square. Factors where one of them is the biggest perfect square that will go in. And I'm going to start skipping steps now. I don't have to break that up. I can just say, okay, 4 is a perfect square. I have my answer. Now what I want to show you is that is much easier this. Neither one of those, 2 or 10, is a perfect square. So I can break that up into square root 2 times square root 10. Duh. I can break that up into square root 2 times square root 2 times 10, which breaks up into square root 2, square root 2, square root 10. Oh, that's a 5. Let's erase. This should be a 5, that should be a 5. And I can say, okay, that's square root 4. Okay, that's a 2. Okay, messy. So if we practice finding the biggest factor, where 1's a perfect, say a biggest factor that is a perfect square will be set. It's going to save you a lot of heartache. Okay, now again, we can break this down into 2 times 10, 2 times 5. I have a pair of 2's and a lonely 5 left. And that's fine, but again, you guys have been making a few mistakes, so I'm trying to give you another option. Okay? Let's try another somewhat hard one. Okay, 48. Now I said you need to find your biggest perfect square. I've got 1, 4, 9, 16, 25, etc. 16 actually goes into 48, and this is when I started to remind you guys to start bringing your calculators to class. Because you had a hard time just dividing by 16, which is fine. You have to know 48 breaks into 16 times 3. So 16 is a perfect square. I can take the square root of it. So I have 4 square roots of 3. Cool. All right. Let's try something a little bit harder. Now we're going to simplify some radical expressions. I have the square root of 147, x squared, y to the 6th, z to the 7th. Whew. Okay, let's break that into pieces. Okay, square root of 147, you start dividing by perfect squares, is actually 49 times 3. And then I have x squared, y to the 6th, and z to the 7th. Cool. Okay, that first one, we got it. 7 square roots of 3. Okay, this next one. Okay, what times itself gives us x squared? Well, x times x is something times itself that gives us x squared. So that one is going to give us just plain old x. This one may be more confusing. What times itself gives us y to the 6th? You have to remember your exponent rules. What times itself gives us y to the 6th? Well, I've got y cubed times y cubed gives us y to the 6th because you add exponents when you multiply. I'll clean that up a little bit. Y to the 3rd power times y to the 3rd power is y to the 6th power. You add your exponents. So that gives us y to the 3rd power down here. Now this one, I have an odd value up there. So I'm going to take one away, and I now have z times z to the 6th. Well, that gives me z times z to the 3rd times z to the 3rd. See how that works? I didn't add power, so I took one z away, and I got an even power, which gave me my answer. So I have z to the 3rd square roots of z. Now we can go ahead and write our answer. Let's collect all the things that aren't under the radical, like 7, x, y cubed, z cubed, and then collect everything that's underneath the square root. 3 and z. So you can do that. That's pretty okay. All right, let's continue with our simplifying. So we've already reviewed the rule square root a times square root b equals square root a times b. We also have the rule square root a over square root b equals square root a over b. Just want to remind us of those. We learned those during the lesson. But right now we are going to remember the rule. So we have these rules. We also have the rules of no radicals in the denominator. For instance, if I have 3 over the square root of 2, I'm not allowed to have that square root of 2 in the denominator. So I need to multiply by, pick what's down there, and give us square root of 2 over square root of 2. Now, what if I wanted to go ahead and divide the square root of 2 divided by the square root of 2? I would get 1. So all I'm really doing is multiplying 3 over the square root of 2 times 1, which doesn't change the value any, which is why I'm allowed to do it. So when I multiply, remember, we multiply across with fractions. I get 3 square roots of 2 over square root of 2 times the square root of 2 is the square root of 4. 3 square roots of 2 over, this is a perfect square, 2. And I get my answer. Let's try another one. 6 over the square root of 3. We take what's down here, and that's what we multiply. Square root of 3 times the square root of 3. Multiply across. I get 6 square roots of 3 over the square root of 9, which is 6 square roots of 3 over 3. Go ahead and simplify. 2 square roots of 3. Cool. What I want you to start doing is remembering things like square root of 2 times the square root of 2. That's really messy. Equals 2. The square root of 3 times the square root of 3 equals 3. The square root of 10 times the square root of 10 equals 10. So you need to just realize that. You don't have to go through each step because you can remember that. We really didn't do any with variables, but they work the same way, right? Cool. Okay, let's move on with operations. Operations just means add, subtract, multiply, and divide. Okay, let's look at something a little bit simpler. I have 4 square roots of 3 times 2 square roots of 3. And then I have 4 square roots of 3 plus 2 square roots of 3. Okay, with this first one, I can multiply what's on the outside, which gives me 4 times 2. And then I have what's under the radical, which gives me square root of 3 times 3. So we have 8 square roots of 9, which is 8 times 3, which is 24. Okay, with the second one, all I can do is group. This is like saying I have 4 apples and 2 apples. That gives me 6 apples. So I have 6 square roots of 3 as an answer. Okay, here we're just grouping with the addition or the subtraction. How about 4 square roots of 3 plus 2 square roots of 5? Well, here I have 4 apples and 2 bananas. B-A-N-A-N-A-S. So my answer is 4 square roots of 3 plus 2 square roots of 5. It's already in simplest form. How about 3 plus square root of 5, quantity squared? Okay, if I gave you 3 plus x, quantity squared, you would say, oh, that means I need to do 3 plus x times 3 plus x, and I need to FOIL. Well, it's the same with these. 3 plus the square root of 5. Let's clean that up a little bit. 3 plus the square root of 5 times 3 plus the square root of 5. I'm going to go ahead and FOIL. First, outer, inner, last. Remember, square root of 5 times the square root of 5 is 5. Collect like terms. I have 9 plus 5 is 14, and 6 root 5. 3 square root of 5 and 3 square root of 5 is 6 square roots of 5. Good job. Okay, I have two more things. How about some subtraction? Well, I don't have the same square root, so I can't do anything except that 28 can be simplified. I can do 2 square root 4 times 7. 4 is a perfect square. So 2 times 4, 8 square roots of 7. Oh goodness, that's hilarious. I'm going to erase the bad math and fix it. 2 times 2 square roots of 7. 4 square roots of 7. Now I can go back and carry this down. It's almost like we did magic. I have 3 minus 4 gives me negative square roots of 7. Right? Because 3 minus 4 is negative 1. I can write negative 1, but I do not have to. Okay, one more. How about 5 square root of 2 plus 3 square root of 5 times 2 square roots of 10 minus 3. I'm going to FOIL. First, multiply the outer number, multiply the inner number. Outer minus 15 square roots of 2. First outer inner plus 6 square roots of 50. And then last minus 9 square roots of 5. See how all that worked? Now let's simplify. Square root of 20 is the same as 4 times 5. See how I just divided it up into a perfect square? And then square root of 50 is 25 times 2. So that becomes a 2. 20 square roots of 5 minus 15 square roots of 2 plus, this becomes a 5. 5 times 6 is 30. Now I collect like terms. Here I have 20 minus 9, which is 11. And here I have negative 15 and positive 30, which gives me 30. There we go. That was our radical review. You have quite a bit of practice problems to do in class next time I see you. So be prepared to practice. Good job.